one way of viewing it is like a system of like coordinates, basically. In coordinates in general relativity, you can choose whatever system of coordinates you like. If you're doing sort of gravitational waves, you'll choose a different set of coordinates than if you're looking at black holes or some planetary system or some binary system. You choose them for convenience because they allow you to sort of think about the world in a more appropriate way or a more convenient way for that problem. So there's no reason to select an interpretation of quantum mechanics. You could just view that as a system of coordinates that you can put on the experiments. They all satisfy the same mathematics, just as different systems of coordinates do. And some are quite useful in certain contexts, like quantum computation. It's very useful to have this set of coordinates in mind, that there are many worlds and what you're looking at is branches when you're doing these computations. It's useful. It's probably more useful than another interpretation of quantum mechanics would be, like the Copenhagen interpretation. It's more natural for that task. But then there are other tasks where a different one is probably more natural. What it shows you, though, I think, is that none of them are fundamental. So when you're dealing with coordinates and you have these symmetries holding between all of these different systems, you know that there is an invariant that all of these are sort of representing. They're all sort of models of this more invariant structure that we call the geometry. That's the geometry. There are coordinates, and they are ways of representing the underlying invariant geometry. And it's possible that there is, in quantum mechanics, something invariant that these are all sort of giving us viewpoints onto. The fact that you can have these things, to me, points to the lack of fundamentality, possibly the lack of fundamentality of quantum theory.
Dean Rickles is Professor of History and Philosophy of Modern Physics at the University of Sydney and a Director at the Sydney Centre for Time. He has worked extensively on quantum gravity and other philosophical conceptual problems in the philosophy of physics. Here we talk about some big conceptual ontology questions in physics. We talk about space-time, time, quantum gravity, specifically string theory, interpretations of quantum mechanics, QBism, some recent and very exciting work on dual aspect monism, and related questions about meaning. If you like the podcast and want to support the work, please consider subscribing to the YouTube channel. That really helps out. Here is my conversation with Dean Rickles. I'm sure you're tired of answering this question a million times, but just to start off with, what happened in 20th century physics that made the need for philosophy so important?
Well, I don't think it was necessarily just in 20th century physics. I mean, it seems to always arise that when there's some necessity for a change in physics, it has to be accompanied with philosophical reflection. Obvious reason being, the fundamental concepts that physicists are dealing with are the ones that philosophers are generally dealing with in broader terms, right? Space-time, matter, causality. So it's natural that when you're undergoing revisions in the fundamentals of physics, you're going to draw on the philosophical work because this is their bread and butter, basically. And they're not wedded to some particular viewpoint with respect to space-time, matter, and causality. They consider a whole bunch of different models, different possibilities with respect to those concepts. So they have a bit more freedom in how they view the fundamental concepts.
Is space-time what drew you to philosophy of physics?
Space-time, yeah. Space, mainly questions of discreteness and continuity were the things that got me pulled in. Just the idea of what space could possibly be made of and whether it was made of anything. Whether it had any kind of structure was the thing that was the first thought that pulled me into physics.
And where have you gone with that today?
I think that it's not fundamental. And there's something, you have to go beneath space and time and look for some deeper structure. It was probably John Wheeler looking into firstly, it was going through the standard theories of space-time and finding problems there. And then, obviously, the quantum gravity work, which is what I've done most work on, and finding that there doesn't really seem to be sufficient progress there either. The only progress that seems to be getting made is where you're probing beneath space and time and finding something, even completely different principles from which space and time are built. So recently I've been looking at Stephen Wolfram's new Ruliad model, and I think it's something like that we're going to have to look to get an understanding of what space and time are.
So time is not fundamental either.
Well, that's a little bit harder. I mean, in the Wolfram model, because so I'll just explain briefly. The Stephen Wolfram's new model is the idea that there is a space of all possible rules or algorithms that are expressed in this total structure, which when taken to its limit, he calls the Ruliad. And then the idea is that we get space from this by embedding observers that are sampling it in certain ways. And depending on the structure of the observers that you place in this Ruliad, you will get different concepts of space, different laws of physics, and they would essentially see a different kind of world. Problem with that one is, in terms of the fundamentality of time, it seems that time has to be built into it because it's a process and it's something that unfolds. You can find a similar kind of view in David Bohm's implicate-explicate order situation, where space is not fundamental, but it seems like some kind of process, at least. If not time, then process is fundamental, and the unfolding of the implicate order is fundamental. So I think it definitely looks like time and space are different and should be treated differently when you take this more fundamental approach.
So is it that the flow of time is the thing that keeps coming up as being fundamental or hard to review?
Yeah, I'm not sure whether I'd call it the flow of time, though. The flow of time suggests something definitely subjective and, an experience. This is more like a process, an evolution, in the form of a process, something like that, rather than something experiential. I mean, of course, there's been a bunch of people recently. Your first question was about why do we seem to need philosophy again, which seems to be the case. And so the way the debate's gone in quantum gravity recently seems to be that there's a bunch of people who think that you don't need time and we can treat it as an illusion. And then you have people like, George Ellis, Lee Smolin, the causal set theory people like Faye Dowker and Raphael Sokkin, who think that there's something really crucial about time and the flow of time. They will happily make reference to the flow of time, the birth of space through this flow of time and things like this. So, I mean, obviously, that what's being dealt with here are the classic philosophical problems, right? Whether time is illusory, whether change is illusory, or whether it's fundamental. It's Parmenides and Heraclitus all over again.
What about the cognitive experience of time? Does there seem to be agreement on what that is, and if it has characteristics that are persistent?
In philosophy, no, there's not really agreement. I mean, there are people that think that, although it seems like the most obvious fact of our experience, and this is what people like George Ellis are basing their views on, that it's like just so obvious that there's a flow of time. Just look. There are philosophers, in fact, my colleague at the Centre for Time in Sydney, who think that we might be in error about whether we even experience the flow of time. It's more like we experience the world as if there were a flow of time, but it might be an illusion too. So, this is it's not a widespread view, but I mean, there's also Christoph Hurl, who's suggested this sort of error theory view, that we might just really be in systematic error about what look like really basic features of our experience. And we're not, we shouldn't feel so sure about what our experience is.
So what are some of the reasons to doubt that?
I think it's mostly based on arguments from cognitive science. I know Christoph Earls he thinks we have a pair of systems. Look, I'm not confident that I can express it quite how they put it, so I won't. I'll just suggest that for your viewers go and look at Christoph Perl's papers and Christy Miller's papers on error theory, but it has to do with sort of the cognitive capacities of the human mind, and it's not as simple as it appears according to their views. Point being, there's controversy even about something that looks basic, like the flow of time and our experience of the flow of time.
So in the quantum gravity approaches, are there any that you tend to favor that stick out to you?
If you'd have asked me this a few years ago, I would have probably said the loop quantum gravity approach, which tends to be the favorite approach of philosophers because it's a bit more familiar to philosophers, the way it's constructed. And, it's no surprise that the original architects of loop quantum gravity are far more favorable to philosophical interactions, thinking about philosophy, speaking to philosophers, doing collaborations with philosophers. And that whole approach was built from the very beginning on pretty much philosophical foundations. The idea was, what is it to be an observable in general and in general relativity? What is it to be an observable? And they started looking at, issues of invariance and identity. And you end up with Leibniz being dragged in because of the principle of identity of indiscernibles and the notions of symmetries and eliminating symmetries. So the whole structure of that theory is infused with quite deep philosophical thinking. Whereas, when you look at something like string theory, it started off as being extremely non-philosophical. It was most extreme kind of initially it was very data-based. I wrote a book on this. It was like essentially sort of analytic continuation and extreme data modeling. So its foundations are completely different. They're much more in standard particle physics. And it's only recently, so I became more favorable to string theory after writing the book, Brief History book, because in more recent times, string theory started considering conceptual questions to do with precisely the ones that started loop quantum gravity in the first place, to do with the nature of an observable. And they were led to this by looking at the symmetries that started appearing, especially in things like ADS-CFT duality. It's hard to make sense of that in their standard terms. You've got two completely different ontologies, and then the standard approach is to look for something that's invariant between the ontologies. So they end up getting led down philosophical paths, down the old philosophical path that led to loop quantum gravity and the canonical approach to quantum gravity. But to answer your question, do I favor any of these? I think there's probably going to have to be something completely different at a different depth of analysis. This is why I've started looking at the approach of Stephen Wolfram, which is, the idea there is that even those laws of general relativity and quantum gravity, and even the laws of mathematics, interestingly enough, come from how we're sampling this Reuliad space. So it's a theory of meta-mathematics and metaphysics, essentially. And you end up with the same explanation of why we have the mathematical laws we do, as you do with why we have the same physical laws that we do, and why we have space-time looking the way it does, and these kinds of things.
Before going into mathematics, are you at all hopeful for the future of string theory?
String theory, I've not seen much development in string theory lately. Not much fundamental development. The last thing seems to have been the dualities. There was a bit of excitement with the fact that you could use these the duality to model interesting things that were sort of, you have phenomena that are non-perturbative and very hard to access in ordinary situations, like the black hole models, quark gluon plasmas and so on. So that's still pretty impressive that you can use string theory to do these modeling jobs, but it's not really what we think of. String theory is supposed to be a fundamental theory of reality, of the cosmos. The fact that you can use it to do these interesting jobs on particular systems seems to be a completely sort of different motivation. You can't really motivate its its status as a theory of everything by looking at what it does in specific systems in the world, as impressive as they are.
Right. Now, the technological applications of quantum gravity theories seem to be totally different from the big ontology questions that we've historically always been concerned with.
Yeah, exactly. It's sort of like I mean, I suppose you should expect this. You get nice, interesting byproducts when you start looking at physical theories, bits of mathematics that can be applied elsewhere, models that are applicable beyond their, initial reason for being created, and things like that. So I think that's more what's happening in string theory, which is interesting because it's keeping it relevant and keeping people investigating it. I don't know. I'll be honest. I've not had a look at in the past couple of years. I've probably not really looked at where string theory has moved. So I probably should see what it's doing these days. See whether there are new developments. But I've not seen any. Have you seen any?
No. I read your string theory book to prepare for this. I was more lost than ever. I'm just kind of going through the old stuff, but yeah, that was about it. I mean, everything you hear is exactly what you said.
Yeah, I suppose it's a little bit different with loop quantum gravity. But yeah, I suppose the difference with loop quantum gravity is that there are these interpretive questions that are at least being investigated still. I don't know. The philosophers should also be investigating string theory as well. I think it's more a case of you have to develop very new tools to go and look at string theory. So it's easier to go and do philosophical analysis of these other approaches.
Yeah, I mean, part of it might just be that Carlo Rovelli has done a really good job in opening those bridges to philosophers and putting conceptual questions front and center.
Yeah, that's true. I mean, there's a few string theorists who started reaching out a bit to philosophers and having collaborations, but certainly not as many. I mean, there's some good stuff being done in dualities at the moment. There's Sebastian de Haro and James Reed, sort of pushing deep into this topic, which is about the most interesting, I think, in string theory from a philosophical point of view.
Okay, so coming back to math, what is your view of the ontological status of math? Are you a Platonist? Do you look at constructivist theories?
Probably constructivist, but again, I would have given you a different answer a few years ago. So I've sort of been thinking, I don't know, probably since the dual aspect monism stuff, which we'll talk about later, just looking at things a little bit differently. So at the moment, I'm immersed in this Rouliad Wolfram material, which is heavily constructivist, basically. And the idea is that there's, I mean, it's interesting because there might be some sort of bulk version of mathematics that's the true mathematics. But the kind of mathematics we usually deal with on this view is constructed, and it's a kind of selection effect from how we're embedded in this space of all possible rules. Think of it as a computational theory. It's a little bit like David Deutsch's constructor theory. I don't know whether you know that theory, where you sort of have a set of almost like build rules. How do you build out from a set of elements using very elementary operations? And so what David Deutsch ends up with is a theory where you're looking at not what's possible in the theory, but what's prohibited in the theory, which operations are prohibited. And then you get things like the symmetry principles coming from this idea. It's almost like a more physicalistic view of how the laws of physics come about. What kind of operations can't you do? What kind of things can't you violate? And that's a bit like, in Galilean relativity, you can't do an operation to reveal absolute velocities or locations and things like that. So the way that this mathematics works in this Rouliad approach is because of our constitution as observers, we're restricted to sampling certain kinds of mathematical rules in this space as well. So it's sort of constructive, but more selective, I would say, like a selection bias almost. So I'm more along these lines at the moment, that mathematics as well is a construction from something more basic, just like space-time and the laws of physics are.
So sorry, I forget what you called it, but the
bulk mathematics. Yeah.
the bulk mathematics. Thank you. What's that about?
Presumably the overall, it's almost like so Arthur Eddington has this really nice description of reference frames in special relativity, and he likens them to walking across a moor, all of the different paths that you could take across a moor, like a field. And the thing in special relativity is that there's also an invariant structure, which is like the version, something like all of those possible paths. It's a thing that has the overall structure that's invariant. So if the idea is that when we're in this Roolead, we see what we see because we're doing something like taking a particular path through the Roolead, a cross-section of the Roolead or something like that, then the natural question is, well, is there something that is the set of all of those possible perspectives, and does it have some kind of invariant structure of its own? And could we ever figure that out from being isolated and restricted, computationally bounded is how he puts it, in this space? Can you figure out what the rest, which is the problem of knowledge, of course. It's like the basic problem of knowledge. We're restricted inside this little box as observers, and we have to figure out what it's like outside of the box, from within it. So that's sort of the point. Is there some global version of mathematics in that space?
So not a big fan of Platonism anymore.
I mean, there's really nice aspects about Platonism. It seems to be well motivated when you hear really the best mathematicians talking about how they think about mathematics. It sounds very much like they are literally walking around in some objective realm and they're able to experience it. So they might be right. That might be how it is. There's a realm in which you can move around and it's real and it's out there. Obviously, this is how Max Tegmark takes it. So there's a few similarities between this Wolfram approach and Max Tegmark's approach. So Tegmark is sort of taking Platonism to the extreme, of course. Right? The idea is that there's nothing but that objective mathematical structure, and we're embedded in it.
Yeah, it seems like when you start with just intuition, it feels like Platonism has to be true. And then when you start thinking about ontology more deeply, then lots of problems come up.
Yeah, I mean, obviously the classic problem is the sort of causal interaction problem, and the how on earth does something abstract like a mathematical structure generate or somehow interact with what we view ourselves to be? So Tegmark has this idea that we are self-aware mathematical substructures, which I suppose could correspond to something similar in this other case I mentioned with the Stephen Wolfram's Roolead. Right? Presumably we are part of that mathematical structure and we are sampling it somehow. So we might be, there might be a similar response there, that we are self-aware substructures of the Roolead.
But the Roolead has a mechanism for how...
It's abstract. It's abstract, though. I mean, you can think of it something like a much more complex version of a Turing machine or something like that. And if it's abstract, then how on earth do we get us having a conversation and apparently concrete events and all, the usual stuff we experience?
What about ontology and quantum mechanics? Do you favor an interpretation there?
Yeah. So at the moment, something along the lines of QBism, understood a bit more like John Wheeler had it. So John Wheeler has this idea that without I suppose it goes back to Bohr's original ideas, if you assume that they're ontological. So without a participator, there is no world, there's no objectivity. So it takes a participator to bring about the phenomena in the world. In other words, the way he puts it, you have to ask a question. No question, no answer. The world doesn't know what it's going to be until you've posed a question to it in the form of, if you're going to take it in terms of experiments in quantum mechanics, you need to tell it what the orientation of your detector is going to be, for example, before it knows what to manifest in an experiment. You need to tell it whether it's going to do a position measurement or a momentum measurement, whether you're going to do that, and then it knows what it's going to manifest. So it's sort of like what Niels Bohr presents as an epistemology is taken as an actual ontological picture, that there just isn't an objective world out there until you've specified some things. And then it knows what it's going to give. And it will be a random answer. There's chance. You won't know what it's going to give you, but you sort of have to give it its frame for giving you the answer. And more recently, this view has been taken into QBism, quantum Bayesianism. Well, it's not quantum Bayesian anymore. It really is just QBism, and that's not supposed to mean quantum Bayesianism anymore. This view of Chris Fuchs and Rudiger Schack and others takes a similar idea that quantum mechanics is basically the tool that you use to navigate the world. So, and there is no sort of objective world out there beyond what these interactions. And quantum mechanics is telling you what experiences you are likely to have, given that you do certain interventions. So it's the participator idea again, and the idea that there's no objective world. What they're doing at the moment, what they've been doing for a while, is trying to, because obviously the problem with this is, and Harvey Brown makes this point, is that this doesn't look like a realism, a standard form of realism in quantum mechanics. And yet the QBists say, no, this is actual a version of quantum realism. They call it participatory realism. And then people like Harvey Brown say, well, yeah, okay, so the participator might be real. Okay. What's the world like outside of the participator? It looks ineffable, is how Harvey Brown puts it. And it is. And that's sort of the viewpoint of John Wheeler. And I think the viewpoint of Niels Bohr sort of mentions some things on his deathbed, apparently, saying that he thinks that there's kind of no objective world when you're not looking. This was obviously the big battle with Einstein that he had, not over the probabilities, but over whether there was a world independently of our observations of it. So the QBists say that it is a realism, and what they're trying to do now is try and put at least some kind of structure into the world out there. But all they end up with is very broad things like the Hilbert space dimension, which doesn't sound like a very good physical property of the world out there. It's not like something you'd ordinarily think of as a property in the world, Hilbert space dimension. But that's about as much as you can get, these very broad, sort of abstract looking qualities. But I sort of bite the bullet and think that there is no world out there until you have specified certain things, and that sort of we're involved.
But as a starting point, QBism isn't trying to be idealist.
This is the strange point. You're sort of being. This is why they end up calling it participatory realism. It's realism, but you have to rethink the nature of the subject-object split. You have to rethink the nature of objective and subjective characteristics of the world. So we would ordinarily think of the world as being out there and objective, and we're going around and we reveal things about the world when we make measurements. We don't make them happen. This is what, this is the whole point of hidden variables, right? You want this idea that the world has its properties, doesn't care what we're doing. You could remove all the humans, all the observers, participators, and the world would still have those same properties. So that's what's being denied, but it's saying that the world is stranger than that. But it's still a form of realism, of reality. The world is a strange place in this QBist approach. And obviously it's hard to, I don't know, I mean, it's hard to describe these things because our usual ways of describing them depend on this idea that there's a subject-object split and a world out there that we are observing and describing and mapping out. That's what's being questioned.
Yeah, I mean, anything in quantum mechanics is hard to intuitively picture, but the subject-object division is just very, very difficult.
Yeah, this is about as out there as probably more out there than the many worlds interpretation in some ways. I mean, that's a bit out there if you really think about it. But
What do you make of many worlds?
well, it's again. So I should just say I'm not entirely 100% about the QBism thing. It's what I enjoy exploring and thinking about at the moment. It may change. Many worlds interpretation is an absolutely brilliant reading of the formalism of quantum mechanics. And this is what's interesting and maddening about physics, but especially quantum mechanics, is that they're all true of the formalism. They're all models of the formalism. They all satisfy, make it true. All of these versions of worlds. So the many worlds can make that mathematical formalism true. QBism can make that mathematical formalism true. So it's tricky. And there's nice things about the many worlds interpretation in its elegance. You know, obviously there's these nice aspects to do with quantum gravity, which is what it was originally constructed by Everett. Or Everett was working under John Wheeler, who was trying to develop models of quantum gravity, understood that you can't have an observer outside of, you know, one of the things that quantum gravity theory is going to investigate is quantum cosmology, treating the universe as a whole, as a quantum mechanical system. Obviously, you can't do that in a Copenhagen interpretation because that would involve having an observer standing outside of the system, which is impossible. So that's why Everett was tasked with he wasn't tasked. I think he just ended up doing, this was his own proposal of getting a theory that didn't involve measurement in any fundamental way, where you had an observer standing outside. Which is why Bryce DeWitt, a later quantum gravity specialist, resuscitated Everett's interpretation in that famous Physics Today article. He saw that something like this was necessary. If you want a picture of quantum gravity and quantum cosmology, this, you know, the Everett approach is giving you the kind of thing you want. So it's very nice, and it's extremely good for thinking about quantum computation, as David Deutsch has nicely, you know, laid out in his book. It gives you a nice sort of physical picture to imagine how quantum computation is running.
Right. No, there's so little known about ontology that investigating these views should be considered the same thing as investing into them.
Yes, exactly. It's funny that some people do. I found it quite curious that quite a lot in our field will be sort of staunch advocates of a particular interpretation, knowing full well that it's no more sort of motivated by the actual formalism and experiments than several others that make completely different claims about the world, about the worldview that it comes with.
Yeah, I mean, I'm 20-something. I can't understand any of them. I'm just going to try to think through as many as I can and see where that goes.
Yeah, I mean, look, they all provide, you don't need to select any of them. You can view it, one way of viewing it is like a system of, like coordinates, basically. You know, in coordinates in general relativity, you can choose whatever system of coordinates you like. If you're doing sort of gravitational waves, you'll choose a different set of coordinates than if you're looking at black holes or some planetary system or some binary system. You choose them for convenience because they allow you to sort of think about the world in a more appropriate way or a more convenient way for that problem. So there's no reason to select an interpretation of quantum mechanics. You could just view that as a system of coordinates that you can put on the experiments. They all satisfy the same mathematics, just as different systems of coordinates do. And some are quite useful in certain contexts, like quantum computation. It's very useful to have this set of coordinates in mind, that there are many worlds and what you're looking at is branches when you're doing these computations. It's useful. It's probably more useful than another interpretation of quantum mechanics would be, like the Copenhagen interpretation. It's more natural for that task. But then there are other tasks where a different one is probably more natural. What it shows you, though, I think, is that none of them are fundamental. So when you're dealing with coordinates and you have these symmetries holding between all of these different systems, you know that there is an invariant that all of these are sort of representing. They're all sort of models of this more invariant structure that we call the geometry. That's the geometry. There are coordinates, and they are ways of representing the underlying invariant geometry. And it's possible that there is, in quantum mechanics, something invariant that these are all sort of giving us viewpoints onto. The fact that you can have these things, to me, points to the lack of fundamentality, possibly the lack of fundamentality of quantum theory.
What do you think about the idea of a limit on our knowledge to be able to understand, like Gödel type limits on how much we can actually understand fundamental ontology?
Yeah, there are quite definitely fundamental limits on our knowledge. We're bounded. We're computationally bounded. Everything is an inference from a very short span of experience. We have an experience that lasts a very short duration. That's all we ever have. And then we make these massive inferences from this tiny snapshot. So we're bounded by that. It's amazing what we do from this little tiny standpoint with our one little snapshot at any moment. But we are obviously bounded, and we're usually bounded by the fact that there's the necessity for a subject-object whenever you're doing knowledge investigation. Whenever you try and know something about the world, this is like the Kantian thing, you have to make a split between the knower and the known. But when you make that split, then you're always doing it from the standpoint of a perspective. So it's always from a perspective. You can never get out of the perspective. It's a sort of delusion to think you can ever step outside of your own perspective and see the world for how it really is. There's always this really fundamental limit.
Sorry if I'm cutting you off.
No, I was trying to think of this nice quote by this cyberneticist, Heinz von Forster, who invented this idea of second-order cybernetics, which is that you have to also put the perspective, the observing subject, into the system that you're modeling as well, and never forget that any knowledge that you're dealing with has come from a perspective of an observer. So something like objectivity is the delusion that there is a way the world really is, independently of the subject or the observer. I think that was the quote. I think that's absolutely true and fundamental. We can never know everything.
Yeah, let's freak you about that. I was just reading about second order cybernetics this morning.
Yeah, it's a very under-investigated area. I don't know any philosopher that's looked into that. I've kind of written one tiny thing on it recently because I was amazed to find this field and these statements and the work of this guy Heinz von Forster and other people around him who were incredibly insightful philosophers, I think. And yeah, well, hopefully, okay, you're reading it as well, so maybe it will start emerging. People will start looking at it a bit.
It was suggested to me by Fred Cummins, cognitive scientist. Yeah, the history of it is a bit weird, where essentially how he tells the story is that there was a lot of focus given to the cybernetics, and then in the 80s or 90s, they just ran out of funding. And then there was this competition between cybernetics and AI, and there was a big DARPA grant, which was basically going to decide what was going to be funded for the next 30 years, and they chose AI.
It is a really weird origin because it started with these Macy conferences in I think the late 40s, early 50s, and what they were doing, oddly, was looking at mesmerism. They were looking at mesmerism and hypnosis. That's what the original conferences were. There were two conferences that weren't published, and then there were these Macy conferences, and that's where cybernetics gets its origins, and the naming, I think, goes around there. We usually say Norbert Wiener coined it. I'm not sure how true it is that he coined the term. Yeah, and then it starts to shift into this more huge organizational framework about how you organize systems in general, and then it interacts with systems theory. So I associate it more with systems theory than anything to do with AI. AI is a part of it because that's one way you can deal with complexity. It's one, or it's an area of complexity. But I mean, what's interesting is it seems to have made a comeback recently, cybernetics. In Canberra, just up the road from where I am, there is a new institute of cybernetics, which really took me by surprise because I thought it was gone. I thought, as you say, that it got overtaken by these other things and became a sort of this archaic kind of idea. But no, apparently it's back. Okay.
Are you using cybernetics for anything, or just curious about it?
Well, I'm looking at second order cybernetics from the point of view of, I mean, so about all of this work on IGUS's, Jim Hartle's idea of an information gathering and utilizing system, and the idea that you try to recreate the experience of the world in a way that fits within physics models. So basically what Jim Hartle did in that thing was second order cybernetics. He's putting an observer, a very limited, minimal definition of an observer, into his models of physics. So I've been looking at different ways of playing around with that and looking at this Wolfram model, right, where you're looking at the world from the point of view of the sampling by a computationally bounded observer. That's also second order cybernetics. You can view it like that. So I'm now trying to bring in and just study what they did back in the day, what Heinz von Forster and co. did back in the day, to see if there's any things that can be brought into this modern physics. This is very early days. I'm working with a guy called Hatem, who is from the Wolfram Institute on a paper on this right now, actually. We'll see how that goes.
Kind of a question from left field, but a bit of a philosophy science question. Looking at fundamentals in physics, what do you make of reductionism today?
Well, it certainly doesn't have quite the power it used to have, and I think possibly the stuff we just mentioned, the complexity ideas, put quite a bit of pressure on the idea of reductionism, as does this shift, what seems to be happening towards information as fundamental. If information is fundamental, well, we know that information is multiply realizable. It's kind of abstract, so it's hard to reduce down to some particular basis because it's multiply realizable. You get the same thing with the complexity models as well. When you're looking at condensed matter phenomena, you seem to get a similar universality where it's hard to reduce down to specific atomic configurations. So I don't think it's doing very well these days, reductionism. I think it doesn't fit where science seems to be going. I think probably for a long time it's been suffering, actually. These problems are well known to philosophers. Maybe not so much to science. Maybe scientists are becoming a bit more aware of them now. It's an extreme difficulty to see how it is remotely possible to speak of reductionism given what we know about complexity theory and statistical physics and condensed matter and renormalization group and the universality of models. It just seems impossible to be a reductionist. It'd be very difficult to be a reductionist. As I say, if you do sort of then take information seriously, then it's really impossible, I think.
Are you happy to see everything as information at the bottom? That approach gets a little bit of pushback these days, but...
Yeah, well, I mean, so the Wheeler thing I mentioned earlier is basically a version of that. So he has this famous saying, it from bit. You get your its from bits, and the way he understands bits is not quite in the same way as sort of Shannon information. It's in terms of yes-no questions. You ask the world a question to get some information, and it gives you a yes or a no. Is this atom spin up? It gives you a 0 or a 1, a yes or a no. That's what he means by it. So people like David Chalmers have sort of taken this idea a bit, but they forget that the fact that they try and reduce things to bits of information, but they forget that a bit of information is absolutely meaningless. It can mean anything, infinitely many things. That's part of the problem of reductionism. What you need is a participator to ask the question first, to put meaning there, to imbue it with meaning, right? And it's sort of confusing the Shannon approach with, I don't know, something more ontological. Shannon's approach, you're never talking about the nature of the bits, what they represent. You don't care about what they represent, right? Whereas when you're talking about what in this Wheeler approach, this it from bit approach, it matters what they're representing, and you tell it by asking a question. You put meaning into those the bits of information.
Yeah, for sure. Information has all its peculiarities that cause problems. Yeah. So, dual aspect monism. How did you come to think about dual aspect monism?
So this was a project that I started with Harold Atmanspacher. So I was looking into some stuff about John Wheeler and also about Arthur Eddington and some other thinkers, and it seemed to be emerging that they were defending something like a dual aspect monism. So dual aspect monism, the idea is that it's usually formulated in terms of mind and matter, right? There's the famous mind-matter problem. What's the relationship between them? And dual aspect monism says that, well, they're actually not distinct fundamentally. Fundamentally, there is no mind and matter. There's just a single thing. And there are two ways of thinking about dual aspect monism. There's one which is sort of the Russellian phenomenalist Markian approach, where you say that there's one neutral kind of stuff, right? So it's like a neutral monism, and everything is built from the same neutral stuff, like almost an atomic approach. The approach we take, and I think is the same as the one taken by John Wheeler and Arthur Eddington and some other people, and David Bohm, very much David Bohm, is that there's a totality. So this is what Bohm would call the implicate order, which doesn't have any differentiation in itself, right? It has no specific qualities. It contains all of the qualities. And then the idea is that this is split in some way, and that's when you get the qualities. So Bohm would say that it sort of unfolds, and then you get the explicate order from this unfolding. So it's a splitting of a neutral substance into these pieces. So it's a bit more like Spinozist kind of dual aspect monism, where you split it into these different attributes. And this fits Wheeler's approach, because what Wheeler does, so remember I said there's no way the world is out there, and then you make a split, and you have to ask a question, and then it gives an answer. You split into subject and object. So that's sort of the idea. The splitting is not fundamental. There are many ways you could do it. What's fundamental is this strange, ineffable, what Harvey Brown called this ineffable sort of reality that gets split. And in order to gain knowledge, we have to do that split. And that's where the limitation that you mentioned earlier comes from. So that's the approach that we were thinking about. And then we ended up writing a book on the subject, looking at all of the different approaches we could find, sort of decent, fairly worked out approaches we could find in physics that could be cast in these terms. And Harold Atmanspacher, who I wrote the book with, his expertise is sort of Pauli Jung correspondence. So Carl Gustav Jung, the depth psychologist, was also interested in ontological issues towards the end of his life, and he had something very similar. And Pauli was also developing something very similar, and they had a huge correspondence where they developed something incredibly close. Not incredibly close. It basically was a version of this theory where there is a psychophysically neutral realm in which mind and matter emerge. So it's amazing to read this. The way physicists think about Wolfgang Pauli is this extremely hard-headed, no-nonsense mathematical physicist. And then you look at those, it's almost like finding Newton's alchemy documents. You look at the letters he was writing to Jung and also his research assistants, who were also into this depth psychology and these alchemical ideas again, actually. And it's a very different Pauli that you see, very mystical, concerned with his dreams, with symbology and all of these kind of things. So there was a discussion of that in the book, definitely fits the bill. Eddington and Einstein are put together in the book because they have this same idea that at bottom there is just bits of information, zeros and ones, and you ask the questions. We have Basil Hiley is still going and working on the approach that he was doing with David Bohm, which is the implicate-explicate order stuff. So we put those all in the frame of this version of dual aspect monism that we develop. And we also include the idea that this has something to do with sort of the creation of meaning, because when you create this split, there are quite obvious connections between the things that are decomposed from this fundamental thing. This is the problem of the mind-matter interaction, is precisely that problem. Why are they linked? Why do they seem to be so closely linked? Well, because when you split this thing, you expect there to be correlations. Just like when you split a quantum state, an entangled quantum state that's in a singlet state, you expect those anti-correlations because they're from the same thing, and they have to preserve the angular momentum equals zero and so on. So you expect it because of how it's been split in the first place.
I had no idea. Sorry.
Well, you carry on.
No, I was just gonna ask you to expand on the Pauli and Jung correspondence. That blew me away that there was a connection there.
Oh yeah, there's a couple of nice books with, I think, maybe the complete letters. Beverly Zabriskie has a book on this, and I think, there's another one. I forget the editor now. So what they're talking. So the story is, Wolfgang Pauli had a bit of a nervous breakdown at one stage. So he was he was dating a cabaret dancer, which is a great idea. So good way to have a breakdown in the future. And it all went terribly wrong, and I think she had an affair. And it was suggested, I think his father suggested, because obviously he's from Zurich as well, so his father suggested that he went he should go and see Jung. Jung didn't see him at first. He sent him on to his assistant, Marie-Louise von Franz, to go get analysis. And they had a bit of a thing going. I think she was a bit infatuated with him, actually. And then eventually he had analysis, and then he gets involved with Jung, mostly through correspondence. And he's sending lots of his dreams about, I think he claims that it looks like his discovery of which one was it? One of the violations of one of the symmetry principles. He kept dreaming about symmetries and which one is it? The violation of in the beta decay, that experiment. Anyway, so there was I can't remember which one it was now, but there was some famous result that he came up with, which apparently comes from his dreams, basically. So he's sending all of this symbology, and they wrote a book together. It was separate chapters, but they actually wrote a book together on synchronicity. So he was completely into this idea of synchronicity. It's famous effects, this famous situation where Pauli used to go into laboratories, and his mental state was so anxious about experiments and experimental equipment that everything in the laboratory would go wrong whenever he went in there. So there's this idea that, what's going on inside is captured by what's going on outside, and he had such sort of strength of thought about everything would go wrong that everything did go wrong in the laboratory, and all the experiments failed. So he had all of these kind of things, these ideas going on. And then they start looking into ancient alchemy. So Pauli starts looking into Flood and Kepler and their alchemical works, and he actually has a chapter on this in the book I mentioned with Jung, which is very surprising if you don't know this kind of stuff already, that he would be writing on mystical aspects of Kepler and Flood, Robert Flood, the alchemist. And their viewpoint was alchemical. The idea was that there is this thing, the unus mundus, which is the one world, this unitary world, which is a bit like what we call the psychophysically neutral realm, and it splits into its parts. And they developed this in their letters at great length. And C.G. Jung's last book, Mysterium Conjunctionis, was an attempt to sort of develop the ontology of this particular view that they were looking at. And it's dual aspect monism. It's this decompositional dual aspect monistic view. There's a totality that gets split. It has to be split because you need a subject and an object to know the world. That's how it's presented. It's very interesting.
So coming back, sorry for that aside, but coming back to meaning.
Yeah. So so basically that's where the meaning comes from. So there's something that links the subject and object that is what emerges when you get this split. That's why we have these meaningful relationships between mind and matter, and between other things that we might find correlated. So it's sort of meaning is the thing that gets generated by this in this decomposition, this relationship between the subject and the object. But I mean, the crucial thing is that we don't take that as sort of ontological. The thing that gets split is not fundamental. What's fundamental is this unsplit, undivided entity, which is the same as David Bohm's thing. He has this book called, what is it, Undivided Universe or something like that.
So then meaning emerges out of the split.
That is the split. That's sort of part and parcel with the split. Yeah. Yeah. So I mean, this is when did we write the book? Like just a year ago. We wrote it in about 3 months, I think, when we realized we had the same sort of viewpoint, and I was studying some things, and then it got written very, very quickly. And we're still sort of, we try and outline some things that you would expect to see if the theory is true. And people used to analyze these things. So this is more Harold's work. He calls them exceptional experiences. If it's true that when you decompose this thing, there are correlations, well, just like with quantum mechanical correlations, you should expect to find statistical evidence of correlation, that they've come from some, initial, whatever, singlet state, if you want to call it that. The mind and matter have come from some singlet state. You should expect to find interesting correlations between the mind and the matter, to do with sort of symbols in the world and synchronicities and things like this. So this is what Pauli and Jung's correspondence go into quite a lot, is the idea of synchronicity, meaningful coincidences between the mind, the inside and the outside. But there's nothing surprising about that if you adopt this dual aspect viewpoint. It's an expectation or a prediction. That's a view.
And just to go back to the start, so the difference between dual aspect monism and traditional Russellian neutral monism is that Russellian neutral monism doesn't have the split entailed. There's just one kind of thing.
No, the Russellian approach is atomic, essentially. It says that there are lots of things you build. It's constructive. There you build the phenomena, whatever it is. You build an experience of whatever, and seeing an apple up. And there will be two ways of viewing that configuration. One from the inside, subjective, one from the outside, objective, but they're one and the same thing. Even though they look different, they're just aspects of one and the same thing that's fundamentally neutral. And all the world is built from exactly the same neutral set of things. Neutral monism. So it's not decompositional, it's compositional. So the difference with ours is that there's one thing, undivided, totality with no differentiation whatsoever, perfectly symmetrical in every possible way. And then you divide it and break the symmetry in certain ways.
Are you bringing this to bear on contemporary consciousness debates?
That's the idea. So it's a different way of thinking about the hard problem, which is how can it be like this? Well, we've come from the same. The mind and the matter are not fundamental. They come from the same source. So it's a different way of thinking about the relationship between mind and matter. And as I said, there should be predictions that you can make about finding things in the world on the basis that they're in the mind and vice versa. So Bohm was dealing with this towards the end of his life. He had this thing called soma significance. And so he was looking at the relationship between the fact that we could make things happen in the world through the mind, basically. And the obvious example is if we get anxious, we can speed our heart up and things like that. Right? A thought can cause things to happen bodily. And then, well, why is that? Well, because they're one and the same thing. They have the same basis.
Are there like classes of distinctions of how you can observe this in the world?
Well, so I mean, Harold's done some pretty systematic work with another colleague of his, Wolfgang, where they're just trying to get statistics of these exceptional experiences. So the idea is not to take them as having any significance. So it's people that have what they would call paranormal experiences, which is not very nice. You don't want paranormal experiences in a scientific discipline. What you want is normal and natural qualities. So at no stage do we want to be leading into things that are paranormal. The idea is to bring certain features that have been called paranormal into the realm of ordinary study and look at the statistics. And weirdly, just like with cybernetics, this used to be a common thing. It used to be completely normal, even in the 60s, probably ended around the 60s, to study interesting experiences, mystical experiences, psychedelic experiences, synchronistic experiences, precognitive experiences. It sounds mad. You can't say anything like this these days without sounding unhinged, but it was completely normal for a long time. It's not completely clear that a lot of those experiments were off. I mean, so Jung and Pauli discuss a lot of the experiments that were being done by this guy Rhine. I can't remember the university. And I don't know, it's not completely definitive that there were any mistakes in those experiments or statistical errors or anything like that. So anyway, it's another thing that could potentially be investigated, but people won't probably, because it doesn't look like the kind of thing you should be looking into if you're a serious academic.
Yeah. Studying mysticism was always a big part of philosophy, and I guess there's just been a stigma that's been associated now.
Of course. I mean, it's interesting to try and find the origins of all of these things. Just like we try and find the origin of the continental analytic splits, and we find that with Husserl and co. I mean, and then what happens is you have people like Heidegger who are on the other side of that split relative to where we would probably position ourselves, who were still investigating interesting things to do with, mysterious things, should we say, the nature of being, and not worrying about whether it looks strange or not, just looking at the nature of being, seeing what follows. Yeah, it's an interesting one. I don't know why it happened or where it happened. William James was absolutely obsessed with these kinds of phenomena. Solid scientists were.
How did William, speaking of James and Gibson, I know you had a chapter on ecological psychology in the book. How did ecological psychology come to?
So, I mean, that's mainly through the idea of in that chapter, we were trying to find examples that put pressure on the subject-object split, basically. And the Gibson, the notion of affordances, and also the idea of action perception cycles, they sort of sit a little bit underneath the subject-object split. It's hard to say where it is, these features. So we just try to elucidate a bunch of those things, and we have sort of examples where the focus is more on the body rather than conceptual content. Again, it seems to be when you get to conceptual content, that's where the subject-object split arises. You could also point to music, absolute music, as another example where it's not conceptual. It seems to be a little bit deeper beneath the subject-object split. And there's loads of writing on the idea that connects us somehow more closely to the fundamental nature of things. Schopenhauer famously associated that with getting us closer to the pure will. Music was basically just an expression of pure will.
Yeah, I know you had a background in music. Did that come to inform this work at all?
Yeah, so another one of the ways into this was precisely looking at two curious elements of music theory, which are tonality and meter. So they're basically two concepts that sit uncomfortably again in this subject-object split. There's a tension, like which side of the subject-object split do we put tonality and meter on? So meter is a strange one because it appears that we're hearing it, meter, right? The actual pulse of music. But we don't, because meter can also go off the actual auditory pulses of music. So in ragtime, the meter is not audible. The meter is a sort of construction that your mind produces, but it's not pure construction, because it needs to bootstrap itself first from the outside signal. It's maddening to try and situate it. So you shouldn't situate it in the mind or in the world or in subject or object. It's something a little bit underneath from which experience emerges. So this is why I put it in the category of something that dual aspect monism can deal with quite naturally. It's a little bit underneath this this splitting into a mind and a world, a mind that's experiencing a world. I don't know whether that was clear, but I mean the point is, so musical meter is not the sequence of sounds that you hear. It's the pulse that your body entrains to. So that it's the thing that you tap your foot to. And in ragtime, your foot will tap off the beat, syncopation. Right? But it had to get in there somehow. You had to be entrained in the first place by the signal that's coming in from the world. But anyway, it's kind of a really weird, objectively weird phenomenon, meter.
Right. There has to be some relation with the world, whatever that is, and then some constructive element, but not really.
Yeah, it's not quite either. Not quite either. Yeah, so this is why I ended up trying to think of it in terms of this approach that Arthur Eddington, the astrophysicist, has, which is called selective subjectivism. So it's sort of the mind selecting things in the world, and there's a subjective element, but it's selecting things from the world as well to try and get some of this across. I mean, the way Eddington viewed physics was in exactly the same way. What we're doing when we do physics is exactly what we're doing when we're doing music theory, which is, it looks like we're examining the world out there, but we're sort of partially responsible for what we're observing as well. So he puts it, we're finding our own footprint when we make scientific discoveries.
Does that have bearing on how we think about laws? How we think about laws of nature?
Oh yeah, that's exactly the point. His point was that laws of nature are selective embodiments of selective subjectivism. So the particular facts aren't. So the fact that the Earth is a certain distance from the sun is a external fact, but the laws of relativity and so on are have to do with our constitution. And again, it goes a little bit back to the stuff I mentioned about David Deutsch. They are prohibitions on what we can do as observers. They tell us about impossibilities about us as observers.
Very tricky to get your head around.
Yeah, it's because there's strange loops that are going on in how Eddington thinks about physics, and in the way Wheeler thinks about physics. I mean, I didn't mention this, but Wheeler has this great diagram that I absolutely love, and some listeners will probably know it, which is sort of this big U symbol, which stands for universe, and there's a little eyeball looking back at the tip of the U, and the idea is that there's a sort of he calls it the self-excited circuit, or the meaning circuit. And the idea is that our observations there's a loop in which our observations bring about the universe that brings us about as observers of the universe. It's very mystical, actually. But it's at the root of his interpretation of quantum mechanics. And it's at the root of it from bit that is now sort of quite commonly discussed, and this will be probably one of those things in the future, as with Newton's alchemy, where we forget how it from bit was developed, namely from these really far out ideas, and we just focus on the it's just information, it's just bits of information. We forget where it came from.
Okay, so the book you wrote recently on meaning in life, do you want to talk about that a bit?
I mean, the idea of that was, it uses something like this participatory realist approach to defend a version of the meaning of life. So the idea is, the book goes through a whole bunch of other aspects of the shortness of life. It's supposed to be kind of a version of Seneca's shortness of life, and sort of expanding it into the modern age and looking at things like hyperbolic discounting, why we're so terrible at planning for the future and these kind of things. It looks at things like the provisionality of life, why we don't seem to be able to sort of engage with it properly. But the overall theory that's presented is that life has to be short in order for it to be meaningful. And, various people have said this, but it provides an argument based on the idea of a possibility space, a little bit like, again, this Wheeler QBism idea. There is a space of possibilities that isn't actualized. It's pure potentiality. And it doesn't know what it's going to be. That's the universe. It doesn't know what it's going to be until you make a decision and have one of them be actualized. So you're sort of involved in creating the particular path, not only your path, but the path that the universe goes down as well. And the idea is if you didn't have a finite boundary, there wouldn't be pressure. There wouldn't be urgency to make decisions and act. You could explore and sample all of these possibilities. So there's this space of possibilities. There's something that forces pressure so that you have to act. And when you act, then you create a particular path for yourself and for the universe. And then the idea is that that's sort of providing you with a huge amount of meaning in how you're engage with the world. You're sort of partially responsible for choosing how the universe goes as well as how your own path goes. And in fact, there's a whole bunch of, there's a couple of chapters on Jungian depth psychology ideas, and the idea of making sure that the paths that you're choosing and actualizing are genuinely coming from you and not from some programming from elsewhere or from some complexes or anxieties or these kind of things. It's a sort of unified argument, but ultimately it's based on this idea from Wheeler, this strange idea, no participator, no world idea, which, it's kind of curious if I think about it, that would be at the foundation of a book on the meaning of life. But yeah, it seems to be doing okay. I think people understand it. It's the first book I've ever written for non-academics. It was an interesting experience to try and do that. Not sure how well it succeeded.